Now, the electric field strength will always point away from a positive charge and towards a negative charge. Is it okay? From the point. Okay. So this is a positive charge according to the equation, and then here is a negative charge. So from this point O, that's from this my point O, now the direction of the electric field strength with respect to the positive charge is away from the positive charge. So it means that with respect to that positive charge at along the x-axis, the electric field strength at this point O will point towards the left, away from the positive charge. Now, with respect to the negative charge along the y-axis, from the point of application, the electric field strength is going to be pointing towards the negative charge. Is it okay? So let me call this man E2. All right, that's a vector. Then now, because this was Q2, I think this was Q2, then this was Q1. So with respect to that positive charge, that negative charge along the y-axis, the electric field strength will, from the point of application, will be pointing towards that negative charge. So it means that we are going to have an electric field strength direction like this. So this is E1. That's a vector. Now, how will the resultant electric field strength be? This is how it is going to be. Is it okay? So this is my resultant electric field strength. That's the direction of my resultant electric field strength. So the first thing is that we are going to, so the resultant electric field strength, okay, is just equal to the electric field strength 1, okay, electric field strength 1 plus electric field strength 2. That is it. Is it okay? Now, remember that these are vectors. Okay, these are vectors. So you are going to write now the electric field strength E1 is this one that is pointing up. It means that, how do I write it as a vector? I'll need to write the magnitude of E1 alongside with the direction. The direction is J. Okay, then plus this other E2. This other E2 is pointing to the left. So it's going to be, I'm just going to put a minus sign, minus E2 magnitude, and then times I. Yes, because it's going to the left, times I. Is it okay? So all we need to do is write down, get the magnitude of E1 and get the magnitude of E2, and we are done with the equation. Is it okay? Now let's start with the magnitude of E1. Anyways, I'm just going to show you how to find the magnitudes. There you apply the formula. So we know that the magnitude of the electric field strength at a point is equal to K, which you know the value, times what? The magnitude of the charge at that point. That's the magnitude of the charge divided by the square of the distance separating the charge and the point. Which means that if I want to find the magnitude of E1, I'm going to take K times the magnitude of Q1. Okay, so I'll take K times the magnitude of Q1 divided by what? The square of the distance from where to where? The square of the distance from the origin to Q1. You know the distance. I think Q1 was at a point 0.4, so the distance is 4 meters, or was it 0.3? Yes, I think it was 0.3, so the distance is 3 meters. I cannot just remember the equation. There you get your answer. Then the magnitude of E2 will be K times, the magnitude of E2 will be K times the magnitude of Q2 divided by the distance, divided by the square of the distance separating the point O and the charge Q2, which is just this horizontal distance. And this horizontal distance will just give you the x coordinate of the point Q2. I think it was 3, something like that. So from there, or was it 4? Anyways, I think you can just check back the equation. Then from there, when you have gotten it, you now write the electric field strength, the resultant electric field strength, as a vector. And that vector will be negative E2, negative the magnitude of E2I plus the magnitude of E1J. Okay, then now you find the magnitude of that resultant electric field strength by taking the square root of the x component squared plus the y component squared, and you're done with the equation.